Hi, my name is Jessie Rice, and my presentation is on non-radiometric dating methods. The first method I'll cover is dendrochronology, which is also known as the tree ring method. A researcher, A.E. Douglas, observed that in areas where there is mild and cold weather, tree growth stopped in the winter and started in the spring again. The fragmented growth periods creates visible rings when looking at a cross-section of the tree. Each ring in the cross-section represents 1 year of growth. So this method basically involves counting each ring to determine the age of a tree. The one drawback is that wood must be preserved well in order to use this method. Next is amino acid dating, which is based on the decay of L isomers after an organism dies. There are two forms of amino acids, L isomers and D isomers. When being viewed under polarized light, the molecules either bend to the left, which signifies the presence of L isomers, or to the right, which signifies the presence of D isomers. L isomers are heavily present in the tissue of living organisms, so when an organism dies, the L isomers turn into D isomers. Amino acid dating can predict how long an organism has been dead by observing the ratio of L isomers to D isomers, which is also known as racemization. And in climates where there's higher temperature, there is a fast rate of racemization. Here's a photo of the molecular structure of the L isomers and D isomers and how they differ. There's also a graph that shows that over time, L isomers turn into D isomers. Next is paleomagnetic dating, which is based on changes in the Earth's magnetic field. So movement of Earth's liquid outer core, which is made of iron alloy, builds an electric current that produces the magnetic field. The magnetic field shift is when magnetic shift of north and south poles occur. During a shift of the north and south poles, metal grains align with the magnetic field and form sedimentary rock. Geologists examine orientation of fragments in the sedimentary rock to figure out the Earth's polarity when the rock formed. When a molten igneous rock is formed, each new layer records polarity, which geologists can study to determine polarity. In the past 6 million years, there have been 4 different periods of polar changes. Next is electron spin resonance dating, which measures radioisotope concentrations that have built up in fossils. A radioisotope whose concentrations are commonly measured in fossils is uranium. After being buried, remains such as bones and teeth absorb radioisotopes and set the level of radioactivity in the burial environment. Typically, an older fossil has greater radioisotope concentrations, and this form of dating can date remains from a few thousand years to more than 1 million years old. Last is thermoluminescence dating, which is based on the amount of the sun's energy that is trapped in materials such as ceramics, stone, or sediment. Thermoluminescence dating measures the amount of light that is released when an object with stored energy is heated. The amount of light released is measured as electrons that are from natural radiation, such as the sun's energy. In this form of dating can date objects back to 800,000 years before present. And here's a photo of a mineral that is heated and is releasing light. This concludes the end of my presentation, and I hope you guys learned something. Thank you.